We are recording this session apparently, so don't turn on your camera unless you really want to be okay, if you really are okay with that and your parents are okay with that. So be very clear on that one. All right, okay, here goes. International Math Salute. Arms free, and it goes as follows. Put your arms out front. Make your hands look really big on the camera. Right hand over left hand. That's the hardest part, right over left. Then you go palm to palm, palm to palm. Then the salute gets weird. You wiggle your little fingers. Where are my fingers? There we are. Then you wiggle your thumbs. And then you wiggle your little fingers again. And then when you're ready, you just come on back. Oh, excellent. You guys did it. I can see it. Awesome. Awesome, awesome, awesome. Some people are still figuring it out, but that is the International Salute to Mathematics. And if you Google International Math Salute, you will find it. You'll find that I'm not lying about it being an International Math Salute because it is an International Math Salute indeed. All right, welcome today. Let's get cracking. It is what about, oh, it's 8 minutes past the hour. So we should get cracking and talk about exploding dots. So we've had 3 lessons so far, all about the adventures of exploding dots, which is fine. And I've kind of kept the lessons kind of independent. So hopefully this one will still make sense if you missed the previous 3. But if you go to the mathcommunities.org website, you can find write-ups of the previous lessons and videos of the previous lessons. If you want to catch up, you can. But let's get cracking today. And I have to start by showing my screen. It's my turn to now fumble because it's always, okay. My connection's unstable. Oh my goodness, everything is falling apart on me right now. Let's stop sharing, let's try it again. Please recognize my camera. Please recognize my camera zoom. Gremlins galore, gremlins galore. All right, well, okay. I am not seeing the means to start my camera. Let's try this again. Where's Zoom gone? Close that. Open up Zoom. Oh, golly, this is fun. This is fun. Share. There it is. I found my camera. Oh, whoa, what a funny day. We're having a funny day. All right, can everyone see this fabulous photograph of this student in Tanzania doing division in exploding dots, which we haven't done division yet. We're getting there. In fact, what we've done so far is, I believe, addition. I think we did addition at one point, or how to add numbers. I think we did some multiplication, which is kind of weird because most people say the one that comes after addition should be subtraction, which is what I should do today. So let's talk about subtraction today. So there's my terrible handwriting, but today's lesson on exploding dots is about subtraction. And it all begins with another story. And this story is also not true. All my stories turn out to be not true. So let me tell you the story of subtraction in a not true story. When I was a child, I used to be, I had a sandbox in my backyard. And every day my parents would send me back to the sandbox in my backyard. I'd sit there. And the first thing I'd do in my sandbox, being a very strange Zen-like child, I would actually make my sand completely level. I've smoothed out my sand and made a nice level surface. And I loved my level surface. But I would sit there for hours admiring my level surface of sand. In fact, I even gave my level surface of sand a name. I was so enamored with it that I called it 0. Why did I call it 0? I don't know, but the story's not true, so it doesn't matter. I called it 0. And I spent many hours, days, weeks admiring my 0 state in my sandbox. But then one day, I had a major flash of insight because I realized I could reach behind me, grab a pile of sand, and make a pile of sand. Whoa, I made a pile, and I called it 1. I called it 1. And then I realized I could do it again. I could reach another pile of sand behind me and make 2 piles of sand, and I called it 2, and so on and so on. Basically, I discovered for myself the counting numbers, and I had to be counting piles of sand. And I had hours and hours of fun admiring my counting numbers as piles of sands. And then I realized I could even do mathematics with them. For example, I realized I could do, when I started going to school, teachers had me do things like 2 plus 3. And in my mind, what I was doing was 2 piles of sand plus 3 piles of sand clearly equals, well, it's right there. I don't need to redraw the picture. 5 piles of sand. 2 piles of sand plus 3 piles of sand equals 5 piles of sand. Whoa, I discovered addition with piles of sand. So exciting. What a day that was for me in this untrue story. But that wasn't the beginning, because now I had, oh my goodness, a major, major flash of insight. Instead of reaching behind me to make a pile of sand, which I called 1, I realized I could do the opposite. I could actually dig into my pile of sand and make a hole. So there's a hole and there's a pile. Whoa. And to me, I realized, oh, a hole really is the opposite of a pile. If I put a pile next to a hole, what I could do is take all the sand of the pile, fill up the hole, and be back at the 0 level state. So in some sense, a hole really is the opposite of a pile. So I decided to call this 1 for a pile. I decided to call this the opposite of 1 for a hole, because it really was the opposite in some sense. But then I was at school, and the teacher said to me, no, 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 young James, don't call it opposite of 1. That's silly. You have to use a little dash, apparently, and write that instead. So apparently a dash means opposite. So, okay, you want me to use a dash? I'll use a dash. But the teachers kept calling it -1. Oh, well, that's fine. That's fine. But that's fine because I could do things like this. 5 plus the opposite of 2. In my untrue story, in my sand pile would literally just be this. 5 piles of sand and 2 holes, the opposite of 2 piles. If I think about it, well, that pile fills up that hole, that pile fills up that hole, and what I'd be left with is 3 piles. 5 plus the opposite of 2 is 3. Great. Except my teachers had another hard time with me. They said, no, no, James, you can't write 5 plus minus 2. We want you to think subtraction, please. Think it as 5 take away 2 equals 3. And I kind of objected to that and say, yeah, I know adding 2 holes really did, in some sense, just take away 2 piles. It really is take away. But I really liked my piles and holes idea. So whenever someone wrote 5 and take away 2, I said, you know what? I don't believe in subtraction. To me, subtraction is the opposite, is the addition of the opposite. I kept saying 5 plus -2. That made perfectly good sense to me. In fact, I think I had an advantage over my classmates, because sometimes a classmate would ask, teacher, what is 3 take away 5? And everyone was thinking, you can't take away 5 from 3. Impossible. So everyone said it was impossible. This is back in the early grades. And I said, no, it's fine. You can totally do it. Don't think of subtraction. Think of the addition of the opposite. In which case, this is just 3 piles plus 5 holes. Sure, I can draw that picture, no worries. I can do it in my sand pile. And I can see this pile fills up that hole, this pile fills up that hole, this pile fills up that hole, and what I'm left with is, I guess, just 2 holes equals the opposite of 2 holes. I had no trouble. I could do that. Everyone thought I was weird, but there it is. So here's the thing. What I was left with in the story, that's not true, because nothing I said just now is true, except for the maths. The maths is true. That I don't believe in subtraction. There's no such thing as subtraction. Subtraction is actually just the addition of the opposite. That's the key point. And actually, that's a really important point. That's how mathematicians actually do think of subtraction. There is no such thing as subtraction. Subtraction is still addition, just addition of the opposite. So if someone writes something like this on the page, James, please work out 6 minus 9 plus 2 minus 1. Sure, I will go 6 take away 9 is -3 plus 2, blah, blah, blah. But really, it's really 6 piles. Oh, I'm not going to draw it out. It's really 6 piles plus 9 holes plus 2 piles plus 1 hole. That's what it really is in my brain. And then you can see that would be 3 holes, and 2 more piles makes 1 hole, add another hole makes 2 holes. The answer must be 2 holes. Beautiful, beautiful, beautiful. Great, so there it is. There's no such thing as subtraction. Subtraction is the addition of the opposite. All right, but here we are. I'm meant to be doing exploding dots. After all, this is meant to be lesson 4 on the topic of exploding dots, which is all about dots. So now I'm gonna have to talk about dots. So here's all these dots, which means I shouldn't be talking about piles and holes. I should be talking about dots. There's a dot. And now, since I'm talking about opposites, I need the notion of the opposite of a dot. Now, the opposite of dot gives me a couple of problems. I could call it op dot, like op dot, or I could call it like anti-dot, like another word for opposite is anti-dot, or I could call it another name. Can people type into chat what you think is the best name for the opposite dot? Could be one of these. But I have a feeling you guys are like me, have an even better name in mind. Oh, I can't see the chat. Where's my chat gone? Okay, well, someone can see the chat and tell me what they're seeing. Oh no, here's my chat. Oh, I'm having a terrible time today. Empty dot. Oh, empty dot is another word we can call it, empty dot, which some people are saying we should draw as a circle. Okay, I can draw circles pretty quickly, so I can draw as a circle. No dot. No dot is a good one. No dot. Yep. Yep. No dot. Any other names we could try? Or we could actually call it circle. You're right, we could actually call it circle. Black hole. Yes, some physicists just won the Nobel Prize for the study of their work on black holes. So actually, yes, black hole would be a very apt name to call it. Be a very apt name. But people that know me and know the story know that I tend to settle on Todd. I tend to settle on Todd, just as Elizabeth just said. Elizabeth said Todd, and I really like Todd because when I go all around the planet, most kids say Todd. And I love Todd because it's beautiful kid thinking. It's just the word dot backwards. It's like the opposite of dot, kind of literally, Todd. No, so a lot of adults will tell me this, but most kids tell me that, which I think is fabulous. So I'm going to go with Todd. I'm going to go with Todd because I think I even called this lesson dots and Todds. All right, so what's the idea? So a dot and a Todd are just like a pile and a hole. Bring a pile and a hole together, they annihilate. Bring a dot and a Todd together, they go poof, and give you nothing. They disappear. It's like, okay, let's be physics. It's like matter and antimatter. Bring a lump of matter together with a lump of antimatter, and apparently they just go boom, poof, and disappear, and you're left with nothing. All right, so that's what a dot and a Todd is, and it means I could do the same sort of math, because what I'm really doing here, this is one pile, and the opposite of one would be 0. That's how I'd do that picture. Or I could do the math I was doing before as a kid, like 5 take away 3. I say, no, 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 my brain says this is really 5 plus the opposite of 3. If I'm thinking dots and Todds, it's really 5 dots together with 3 Todds. And I can see some annihilations, like a dot and a Todd, poof, disappear. Dot and a Todd, poof, disappear. Dot and a Todd, poof, disappear. And my picture's messy, but you can see I'm left with 2 actual dots. So all the math I was doing with piles and holes, I can now do with dots and Todds, and it's still the same, and it's all good math. All right, that's great. So now I've got a system to do here. Let's now go back to school maths. So we did addition, multiplication. Now it's time to do subtraction. 536, take away 123. So remember, everything we're doing in this story is base 10, because we're living in a society that likes base 10 a lot. So I'm doing what's called a 10-1 machine. We have a box for the units, a box for the tens, a box for the hundreds, a box for the thousands, a box for the 10,000, 100,000, and so on. And 536 is literally what I just said, 500. 5 hundreds, there they are, 5 actual hundreds. 30 is a weird way of English of saying 3t, and ty means 10, is a weird way of saying 310. So we say 30, but it means 3 tens. And 6, 1, 2, 3, 4, 5, 6. Now, I don't believe in subtraction. To me, subtraction is the addition of the opposites. I need to add the opposite of that. So I've got 100 here, but I want to add 1 anti-100, 1 Todd. Add 2 anti-tens, 2 opposite tens, 2 Todds. Add 3 anti-ones, 3 Todds. So to me, this subtraction problem is really that addition problem. Some dots added with some Todds. And I can look at it and say, oh, look at that. Dot Todd, poof, they disappear. Dot and a Todd, poof, they disappear. Dot and a Todd, poof, they disappear. Dot and a Todd, poof, poof, and poof, 3 disappears right there. And I'm left with, probably need a different color, it's getting messy, with the answer 413. 413, which makes perfectly good sense, as though I go 5 take away 1 is 4, 3 take away 2 is 1, 6 take away 3 is 3. So I want to do subtraction, I can do it, and I love it. Just do it. Just do it, actually. I love it. Just do it. And there's the answer, 413. 400, 1T3, 110 and 3. Beautiful. Now, you might look at that and say, you might have noticed something strange I just did. Because in addition, if you remember, everyone's taught to go right to left in math, and I did addition left to right. You might have noticed I also did just my subtraction then left to right as well. 5 take away 1, or 3 plus anti-1 is 4. 3 plus anti-2 is 1. 6 plus anti-3 is 3. Left to right is good. Which makes you wonder, what if I did a nasty example? Like 512 take away, I don't know, what's a good, 347. How's that? All right. 5 take away 3 is 2. 1 take away 4 is negative 3. 2 take away 7 is negative 5. The answer is 200 negative 3t negative 5. 200 negative 3t negative 5. Done. Beautiful. Easy peasy. In fact, if I draw you a picture, I can show you this is absolutely correct. 5 hundreds, 5 Todds. 110, 1 Todd. 2 ones, 2 Todds. Please, sorry, dots. Now add the anti this, the anti-dots, 3 anti-dots, 3 Todds. Please add 4 anti-10s, 4 Todds. Please add 7 anti-1s, 7 Todds. Beautiful, beautiful. There's the picture of that. Are there some annihilations? You bet. Poof, dot, Todd. Todd, poof, poof, poof. Todd, poof, poof. And I'm left with, I was doing green before, 200s, 3 anti-10s, 5 anti-1s. Beautiful. 200, -3t, -5. Done. Love it. Fabulous. Okay. What do you think of that answer? Do you like it personally? Just type in yes or no into chat. I'm just curious if you like it or not. Or some people saying yes already. 2 people saying yes already. Someone saying no. Yes, no, no, yes. All right. All over the place. Yes. Okay. All right. That's fine. I am a professional mathematician, by the way. And actually, as a mathematician, I actually have no trouble with this answer. I think it's fine. Thumbs up from me. But I do admit that society thinks that's weird. Society doesn't like that. So it sounds weird to our ears. You're right. Society would not like it. Some people love it and they recognize society won't like it. And some people don't like it because it sounds so unfamiliar for our ears. So that gives us a challenge now. What could we do to fix up this answer, which is technically mathematically correct, that's into a way that's acceptable for society? Any thoughts on how we could fix up that answer for society's sake? Society won't let me say 200 -3t -5. Yeah, this is tricky. Explode some dots back. Oh my God. Okay, I see 2 ideas. I see 2 brilliant ideas there, and I'm going to do both of them. The first one I saw was explode some dots back, and the second one I saw was think of 200 plus 35 Todds. Got it. Okay, so here goes. The first one, unexplode some dots. You're right, you're right. If you think about it, this is brilliant actually. This dot here really was 10 dots over here that explode, kaboom, to make that 1 dot over there. So actually, I could unexplode it. Now, I need a sound effect for unexploding. Yeah, I can do a sucking sound. Unexploding is going to be, bring it back to being 10 dots over here for 5, 6, 7, 8, 9, 10. So 1 dot there really was 10 dots there. So now I have the answer 100, an extra 10 dots there. Except some annihilations. Poof, poof, poof. So it's really 7 there, -5. The answer is 170 -5. Better, that sounds good. 170 sounds good to society. That -5 doesn't sound good to society. They don't like that one. Oh, society is so demanding. But you can do the same idea again, unexplode again. Take this dot here, realize that this dot was really 10 dots from over here. So unexplode and make it 10 dots over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I made an extra 10 dots there and 1 less dot there. Annihilations. Poof, 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 poof. And that leaves me with 5, 165. Oh, love it. Love it, love it, love it. Okay, there it is. That fixed up. I think society would like that answer. They have no trouble with that answer. That's fine. And then someone else said, think of this a different way. Maybe you can just actually see the answer right there. The first thing I did. When I went left to right, 5 take away 3 is 2, 1 take away 4 is -3, 2 take away 5 is -7 is -5. Well, that 2 there is really 200. That 3 there, anti-3 there, is really -30. And that -5 there is actually -5. Actually, you see, if you're good at doing arithmetic in your head, which I'm not doing good at, 200 take away 30, take away 5 is 165. So actually, maybe we could have seen the answer right away. Whoa, whoa. Okay, 2 brilliant ideas turned out to both be brilliant. Fabulous. I love it. I love it. Thumbs up for me. There we go. Thumbs up for me. All right, all right. I am curious what school books teach us to do. If I had to do 512 back and take away 347, when I was back in Australia, grade 4, grade 5, year 3, 4, 5, somewhere around there, we had to do lots of these. We had to do like thousands of these. We had to do like worksheets upon worksheets upon worksheets of these. And I was taught a very strange way to do it. Probably might be familiar. Maybe everyone does it this way. Of course, I was in math class. Apparently, everything in math had to go right to left. So we had to go start on the right. And we had to go 2 take away 7. And people remember said, they can't do that. You can't do 2 take away 7. Well, I can. It's -5. We knew that. It's 5 wholes. But you're not allowed to write that. So what do people do? What do people say you have to do? Can you type it in chat? Because I don't know the language. What's the language in America for what you have to meant to do? What do people call it? Borrowing. Borrowing. Okay, borrowing. Okay, borrowing. That means you want to take one of these dots, like we took one of these dots over here, and get rid of it down to 0 and make an extra 10 dots there. Is that right? Is that what we meant by borrowing? It's really actually unexploding. Aha. Oh, by the way, I don't think, if I remember correctly, you don't write 10. Because apparently ink is very precious. You have to save ink. No, no, don't waste ink writing a 0. Put a little 1 right next to the 2 and make it 12. That's really like 10 and 2 is 12. Is that what you have to do? Because I had to do that. Because then you know, now you can say 12 take away 7 is 5. All right, great. Let's make my 5 look better. Okay, 0 take away 4, -4. Great, happy to do that. 4 holes. No, 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 10, you're not allowed to do that. So again, you take one of these dots, make it, leave 4 behind, make an extra 10 dots there. No, no, don't waste ink. Don't spend an extra ink on the 0. Write it like 1, 0 there. That was an unexplosion. 10 take away 4 is 6. And then 4 take away 3 we can do is 1, 165. Whoa, whoa. Okay, here's the truth. I was taught to do it that way. I was very good at doing it that way. I got all the gold stars on my worksheets because I was such a good little student back then, and I got the answer 165. But nowadays, my brain actually does go left to right. I actually do that in my brain, and I quickly fix up the answer. I don't need to draw the picture anymore because I've drawn enough pictures, at least in my head, I can see what to do. Then I kind of actually just do what, was it someone else said? Who was it said? Ben and Alex said, just think of it this way. I actually kind of do that too now. But you know what, it's all good. If you want to go right to left and do these borrowings, these unexplosions as you go along, it works. All good math is good. That is good. This is good. This is good. It's all good. Math is good. There's a lot of exclamation marks, tick marks. Excellent, math is good. All right, just for fun, on your ownsies, try this one. Try it the James Tanton, let's not worry about what society thinks way, and then fix it up for society. Can you do that one? Just write down the answer in 3 seconds with no regard to what society thinks, and then see if you can fix it up. Yeah, I like that answer. Ben and Alex are writing that. Actually, here's the fun part. How do you say it?
2000 -100 -41 -1. I don't know.
-40 -1. I agree. That was it. 2000 -100 -40 -1. Society doesn't like that. I agree with the answer. I think it's a great answer. Like 2 take away 6 is indeed -4. 6 take away 4 is 2. 3 take away 4 is -1. 8 take away 9 is -1. In fact, you can do it in any order you like. You can just be random order. Go left to right, go right to left, go any order. It's all good. Love that answer. All right, now the hard part. Society is demanding. Society doesn't like that answer. Society doesn't want that answer. Can you figure out how to fix it up for society's sake? What will we have to do to fix it up for society? Yep. Ben and Alex are doing their approach. I like their approach. And Alex is saying, I think this is 2000, an anti-100, an anti-40, and an anti-1. Maybe you can do that in your head. I'm not good at that. Or you can think of that as 2000 and 141 tods. Yeah, so that must be dots and tods. Okay, that works too. Maybe you can do that in your head. Okay. Unexplode. We can unexplode. Yep. Actually, there's lots of ways we can do it. Unexplode. It's probably what I do in my head, or actually I can't do this one in my head. I have to do it on a piece of paper. Okay, if you do any of these methods, what do you get? What's the correct answer? And then I'll see if I can do it too on camera in front of everyone under pressure. I'm nervous about doing under pressure, but I will. $1,859. Apparently this is 1,859. Okay. All right. Okay, here goes. I'm going to do it. I'm going to imagine I have a picture of dots and tods in my brain, but I'm going to take one of these dots here and leave one behind and make an extra 10 dots there. So that's an explosion. So that's really 9 dots there. So now at 1,900, negative 40, negative 1. And I'm going to do that again. Take one of these dots, leave 8 behind, and make it 10 dots there. Okay. 10 and negative 4, that's going to be 6 actual dots. So now the answer is 1,860, negative 1. Do it again. Take one of these dots, leave 5 behind, and unexplode it to 10 there. Oh, beautiful. And that's going to be 9 there. 1,859. 1,859 is what you guys said. You are fabulous. You're good. This is great. Your reward for doing such a clever one is to have an even worse one. Here's an even worse one. Do this one. Do it the James Tanton, we don't care what society thinks way. And then fix it up for society. Oop, hey, well, try and do alignment for you. Or you can say, no, I don't want to do it because it's horrible. That's an option as well. Your own fabulous selves, you can say, no, I don't want to do it. It's so fun not caring what society thinks. I love it. I'm training rebels, sorry. Yeah, some people are writing answers now. It looks like they're the same answers. If it's the same answer, it must be correct. I'm going to believe it. What am I getting? 4, 6, negative 1, 0, negative 5, negative 6, negative 1, negative 5. So what people are typing, maybe I'll just put vertical bars to make it easier to see the differences. 4, 6, negative 1, 0, negative 5, negative 6, negative 1. Yes, excellent. All right. Do you want to try to say that answer? No. Maybe, yes, I don't know. It's a hard one to say. Maybe put some commas in. We like commas in how we write numbers. Yeah, this one's hard to say because English is just weird. It doesn't like that one particularly. I mean, I can see 46,000, negative 100, negative 5. Oh, sorry, no, 46 million, negative 100, negative 5,000, negative 600, negative 1t, negative 5. But negative 1t, they don't even like 1t. So they want to make us say negative 15 or something. I don't know. It's hard to say. That one's hard to say. All right, but now the next question is, what's an answer that society will accept? They won't accept that one. Could you now fix up that answer for society's sake? All right, someone's got answers already. They are speedy, much faster than me. Oh, yep, Ben and Alex are doing their thing again. Absolutely, love it. Now, can you actually work out what that is for society's sake? Whoa. All right, all right. I see some people have finished. I don't know. Let's see if we all got the same answer. I'm sure it's so easy to make mistakes here. All right, that 4 is fine for society. That 6 is fine for society. that -1 is not fine for society. They won't like that. So let me see if I can unexplode 1 dot from here, leave 5 behind, and make an extra 10 there. There's my sound effect. That means I've got 10 dots and 1 Todd. That means I've actually got 9 dots there. Bingo, that's a bit better. That's great. Ooh, the 9 is fine, the 0 is fine, except, uh-oh, that -5 there, which means I should unexplode a dot from there to make that better, but there is no dot there. Oh no, I've got a problem. What am I going to do? Someone's typing. Oh, take one of the dots from here, make this 8, and then make that 10. Now I've got a dot here I can unexplode. Yes, brilliant, brilliant, brilliant. Darla and Rose have got it right. Take one of these dots, make that 9, an extra 10 dots there. 10 dots and 5 anti-dots does make 5 actual dots. Whoa, save the day. All right, so 4, 5, 8, 9, 5. Oh my goodness, we can keep going. 1 dot from here, leaves 4 behind, makes 10 there. So now I've got 4. 1, 5, 8, 9, 4, 4. Oh, okay, here goes. Do again. 1 dot from here makes 10 over there. That's 9. 1, 5, 8, 9, 4, 3, 9. Oh, again. Right, 1 dot from here makes 10 there. That's 5. 4, 5, 8, 9, 4, 3, 8, 5. Is that what people wrote? Looks like it is. Oh, golly gee. Yes, we can do it. We can fix up society. Society is just so demanding. I like my first answer way better personally. Okay, but what can I say? This is the world we live in. All right. So that's it. That's all I want to talk about today in terms of the actual exploding dot story. But maybe in the last 6 minutes, let me just give you a general puzzle. If you want something that's a little bit deeper and more tricky to think about, try this puzzle. So here I am working on the spot with a puzzle. This is completely optional. And I'm going to do this puzzle not in base 10, the 10-1 machine. Let's do it in a 2-1 machine. So a 2-1 machine, if you remember, 2 dots here explode, kaboom, to make 1. 2 dots here explode to make 1. 2 dots explode to make 1. And we realize the value of the dots were given by the powers of 2, these doubling numbers. So actually, I'm going to just do the first 5 boxes. I will stop the machine there. So the machine stops here, and it's just between the box of value 16 and the box of value 1. And the game I want to do is put a dot and a Todd, one of them, in each and every box. I want to make sure every box at least either 1 dot or 1 Todd. So maybe I'll put a dot there, maybe I'll put a dot there, maybe I'll put a Todd there, a dot there, and a Todd there. The question is, what number is that? Well, that's a 16. That's an 8. So a 16 and 8, that makes it 24. I've got an anti-4. That brings me back down to 20. Then I've got actual 2, gets me up to 22. Then an anti-1 brings me back down to 21. So I've got the number 21 if I do that pattern. Okay, so I want 1 dot per box, or 1 Todd per box. And let's try something else. In green, what if I made, say, a dot there, a Todd there, a Todd there, a Todd there, and a dot there? What number is that? Is it 3? I can't do it. I can't do arithmetic. I'm terrible with arithmetic. Is it 3? Can I get it confirmed? Someone says it's 3. Can we get that confirmed? If someone else types in the 3 into the chat, I'll believe you. Yes, 3. All right, 3. Okay, that's the game I want to play. What numbers can you get by just putting dots and Todds randomly, 1 per box, in a 2-1 machine? You might start noticing different types of numbers of a certain class keep appearing. What are those numbers? So if we've only got 3 and 21, I can't tell much from 3 and 21. They're both multiples of 3. That's something. What numbers occur in a 2-1 machine this way? That's my puzzle for the week. And if you start noticing a pattern, like which types of numbers appear, can you explain the pattern? That would be very interesting. All right, so there I'm going to stop for the day. Dots and Todds, love them. Subtraction doesn't exist. Subtraction is the addition of Todds and actually makes your life much easier. You can go left to right, you can go right to left, and you're any order you like. Great, you'll get a fabulous answer. Only trouble is you get an answer that society probably won't like, but no problem. You know how to fix it up for society. This is grand. This is grand. So on that note, I'm going to say thank you so much for coming today. I really appreciate it. I'm not sure if this lesson ended up being recorded in the end, because if I'm the host, I didn't press any record button. So maybe this lesson wasn't recorded, in which case this lesson was unique to you. Well done.
It was recorded.
It was recorded, in which case, yes, this lesson is not unique to you, but you're the first to see it. And that way you're special. All right, so great. So there's a good puzzle. Feel free to email me. I'm very easy to find if you want to know what's going on with this little 2-1 machine puzzle. But next time, we have to get to the big one. We have to get to this stuff, division, and do crazy things like this fabulous student is doing on the board here in Tanzania. So next lesson, I'm afraid, is not next week, because next week is Global Math Week. In fact, I'm doing all the lessons every single day of Global Math Week next week. So if you want to do it all again with me, come on Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, and a bonus lesson on Friday. And then otherwise I can see you the following week back on Wednesday for lesson number 5. Yes, I can count 5. So I'll stop sharing my screen and say, thank you for coming along. Take part in Global Math Week. Do some exploding dots with someone. If you do exploding dots with someone next week, just let us know on social media that you did it. The hashtag is, I should tell you the hashtag. Hashtag is, it's very hard to remember. I can't even write it, my handwriting, hang on. It's hashtag GMW2020, Global Math Week 2020. That's it. So if you do little exploding dots with someone next week, let the world know that you did it, what they thought of it, and then you'll be part of about 6 million people doing the same thing, which is amazing. 6 million people across the planet all doing exploding dots all in the same week. That is incredible. GMW 2020. Thank you for putting it in the chat. I appreciate that. All right. Be well. Have a good week. Be safe. See you next time. Bye-bye.
Bye, thank you. Also, just so you know, I'm pretty sure I've seen this before on your Floating Dots website, and I'm pretty sure I know the answer.
Awesome. Awesome. Perfect. Then your challenge is, how do you take that puzzle and make it even like a next level up? What if I did it for a 3-1 machine or a 4 machine? What's the 3-1 version of that puzzle? That's cool. That would be cool. Okay. Fabulous. Thanks, everyone.
Bye.
Bye.